This is an RNZ podcast. Kia ora and welcome to Elemental from RNZ, a podcast celebrating the International Year of the Periodic Table. I'm Alison Ballance, and today's episode, number 77, is about a real salt of the earth element.
I'm Allan Blackman from the Auckland University of Technology, and I'm going to kick off with a question for you, Alison. Would you willingly eat the product obtained from the reaction of a metal which reacts violently with water and a poisonous gas that was used as a chemical weapon in World War I?
Well, when you put it like that, no thanks.
But your answer to this question is, in fact, yes. Chances are you've actually already eaten some today, because the product of that nasty-sounding reaction is sodium chloride, or, as it's better known, salt.
Because, of course, we are up to sodium. Take it away, Professor.
Okay, sodium. The name comes from the English word soda, or also possibly from the word sodanum, which is a medieval word for headache remedy, of all things.
Well.
I know, who knew? The elemental symbol is Na, which you wonder how they get that from sodium. It actually comes from the Latin natrium, and which was the Latin for sodium carbonate. It has the atomic number 11. That puts it in group 1 of the periodic table right near the top left.
Well, we've had a taste for salt, that's sodium chloride, for a very long time, and we still do, in fact. But how long have we known about it as an element?
I'll digress slightly here before answering your question exactly. There are some names on elemental that seem to have cropped up over and over and over again during this series, and the name Humphrey Davy is one of them. So, in relation to sodium, he, in 1807, used electrolysis to be the first person to isolate pure sodium. And this was the second element to be isolated in this fashion after potassium. Humphrey Davy had a real purple patch, I guess, in the early 1800s when it came to discovering elements. So, sodium is a group 1 metal, and that means it's going to be very reactive with water, amongst many other things. And I'm sure many listeners will have seen their school teachers dropping variously sized pieces, or indeed chunks, I guess, of sodium into beakers of water and standing back.
Ah, yes, there are plenty of videos on the internet of people, mostly blokes, I have to say, chucking those various sized pieces of sodium into variously sized bodies of water, always with very dramatic results. And I take it from that it's so reactive you just don't find bits of it lying around?
Yes, very reactive indeed. And in fact, there is a wonderful clip on YouTube of, I think, the US Army disposing of, I don't know, it might have been a ton of it or something like that. Just
good gracious, I didn't find that one.
Have a look for that, it's impressive. But yeah, you're right, you don't just find it lying around because of its reactivity. It's the 6th most abundant element in the Earth's crust. It's never found in its elemental form, though, because of the fact that it is so very, very reactive. And so instead, rather than existing as the element sodium, it exists essentially exclusively on Earth as the sodium plus or the Na plus cation. And it does almost appear that its only purpose on planet Earth is to neutralize the charge of more interesting anions in salts. For example, the active parts of 3 compounds: sodium bicarbonate, otherwise known as baking soda, sodium stearate, which we better know as soap, and sodium azide, and that's the material used to inflate airbags. So the interesting bits of those 3 compounds, not the sodium, it's the anions. It's the bicarbonate, it's the stearate, and it's the azide. And the sodium is there just as what we call in chemistry a spectator ion.
It's like being the bridesmaid all the time and never the bride.
So if you put any sodium salt into a flame, you get a beautiful orange coloration. And that orange coloration should remind you of streetlights, the beautiful orange colour you get from some streetlights, as they also, in fact, involve excited state sodium atoms emitting light. That's what's happening in both processes. But really, that's about it for sodium until we get to the human body.
Okay, so we're going from salt of the earth to the salt of life then.
Yes, and this sort of saves sodium, I guess, from becoming a boring element. So if we go back to the potassium episode where we discussed this, we know that a balance between sodium and potassium ions inside and outside cells is absolutely crucial to the transmission of nerve signals in the body. And too much of one or the other, and we are in trouble.
That's right, a quick recap. The sodium-potassium pump pumps 2 potassiums into a cell and 3 sodiums out of a cell, and they're both going against their concentration gradients.
Yep. And because of that, the pump is, in fact, quite energy intensive. So the energy source is a molecule called ATP, adenosine triphosphate, and that uses around about 25% of the body's energy. And in fact, in the brain, it's around about 75%, which is quite extraordinary. In terms of health, high levels of sodium ions have been linked to high blood pressure, but the link appears far from certain. The Japanese eat a lot of salt, but have a very high life expectancy.
Oh, Alan, I disagree with you on that uncertainty. There's good evidence of strong links between salt intake and hypertension. But this begs a question. Let's just put that to one side. What is a salt exactly?
Yeah, in fact, we have been using the word salt possibly all the way through Elemental without really defining what it is. So now is the perfect time. So if I say the word salt, that word would be generally understood by the public to mean that it's the stuff that you shake on your food, or in other words, sodium chloride or NaCl. However, when I, as a chemist, say that word, and when I say chemist, I've really got to stress that chemists are not the people who own the shops and the malls. They are pharmacists, okay?
Oh, you pedant, you.
Please don't talk about chemist shops, for example.
But we did in the last episode.
Oh, dear. Okay, I meant to say pharmacists, sorry.
Okay, so Alan got it wrong last time. He meant pharmacist, not chemist.
And that would not be the first time, believe you me, Alice. Anyway, digressing, or not. So to chemists, when we say salt, a salt is any chemical species that contains both a cation, which is a positively charged species, and an anion, which is a negatively charged species. Okay, so salt, I guess, in the chemistry vernacular is a lot more general term than, I guess, in the general public's vernacular. Okay, so humans lose salt through sweat.
And my favourite thing is one of the reasons that cats and dogs like licking us so much is we often taste really salty, especially if we've just been exercising.
Indeed. And sadly, that's one of the reasons that we've now entered the era of a thing called the lifestyle drink. Honestly, go to your nearest supermarket, look down the aisles, and you will find an aisle named the lifestyle drink aisle. I'm still at a bit of a loss to figure out what these in fact are. The best I can do is that they appear to be sugary drinks containing things called electrolytes. It's a very impressive sounding name until you realise that electrolytes are just salts. And in fact, an electrolyte is anything that, when you dissolve it in water, will cause the resulting solution to conduct electricity. And all salts do that.
Right. Point taken. Now, the saltiest place that I can think of is the sea.
Yep.
So how much salt is there in the sea and why is it so salty?
Well, on average, seawater in the world's oceans has a salinity of around about 3.5%, or to put it another way, 35 parts per thousand. So in other words, for every litre of seawater, there are 35 grams of salts. Not just salt, salts. Mostly, but not exclusively, sodium chloride. And in fact, by the way, we're talking about sodium. So sodium only makes up around about 40% of the mass of salt.
Just being that bystander again.
Indeed. So the NOAA, which is the National Oceanic and Atmospheric Administration in the US, says that if the salt in the ocean could be removed and spread evenly over the Earth's land surface, it would form a layer, get this, more than 150 metres thick. And that's around about the height of a 40-storey building. So, yeah, there's a fair bit of salt in the oceans. Where does it come from? So basically, rain contains some dissolved carbon dioxide, and that makes it slightly acidic, and that then breaks down rock, and that releases ions, and they all then flow down the rivers into the sea.
That's an excellent answer, thank you. May I please have a random interesting fact?
Yeah, okay, so again, we're struggling for sort of uses of sodium, but perhaps the strangest use of sodium is as a coolant in nuclear reactors. And we're talking liquid sodium here. So this has been used in a few mostly experimental reactors. It turns out liquid sodium is very, very efficient at removing heat from the reactor core, but I, for one, certainly wouldn't want to be around if the plumbing ever sprung a leak.
Oh, me too. One of those great in principle but not so great in real life ideas then. Unlike the Elemental podcast, which was a great idea, and thank you, Alan, for suggesting it, and it's equally good in reality. Elemental, shining a light on the as common as salt parts of the periodic table, as well as its darker, dingier corners. And if you'd like more than just a pinch of salt to liven your day, there are now a grand total of 77 episodes waiting for you on the Elemental webpage, rnz.co.nz/chemistry.
And of course, head to RNZ Elemental on your favourite podcast provider to find our chemistry corner of the internet. We are back next time with strontium. But until then, it's cheerio from me, Allan Blackman.
And me, Alison Balance. Mate wa.